Hello everyone, my name is Devin Chu and I'm a postdoctoral researcher with the UCLA Galactic Center Group. Today I will be talking about how do we find something we cannot see. The UCLA Galactic Center Group is interested in studying the black hole at the center of our galaxy. However, a big challenge to do this is that black holes don't emit their own light. So if that's the case, how do we study it? And how do we even know that there is a black hole there in the first place? I will begin by introducing the concept of gravity. Gravity is a force that depends on the mass of an object. The planets in our solar system orbit the sun because of gravity. Gravity doesn't just apply to our own solar system, it also affects anything in our universe that has mass. If we were to replace the planets in our solar system with stars, and the sun with a black hole, the stars would still orbit an object because of gravity. The UCLA Galactic Center Group is very interested in looking at stars at the very center of our galaxy. To do this, we point telescopes toward the center of the Milky Way as shown here. We use really interesting technology such as lasers to see the stars in this region, and we've been doing this for the past 25 years. Over the course of these 25 years, we see the stars move. In fact, if we focus on this star here, SO2, we see that it happens to have a complete orbit around something, which is really interesting. Here is the tracing of its path on the plane of the sky. Here is another animation showing the stars at the galactic center. These stars are orbiting around a massive object that is dark and not like another star. Using the laws of gravity, we were able to determine that this object is 4 million times heavier than our Sun, and is located in this region here. Interestingly, we also know that this object of 4 million solar masses is squeezed into an area about the size of our solar system, which is pretty small for an object so heavy. In fact, our understanding now is that this 4 million solar mass object is squeezed into an area a little larger than our Sun. To put this into perspective, this would be like compressing all of the mass of the Earth into the size of a sugar cube. As another example, this would be like compressing all of the mass of the Sun into the size of downtown Los Angeles, basically from Dodger Stadium to Staples Center. And so by tracking the motions of these stars at the galactic center, we've realized that these stars are orbiting something with so much mass in such a small volume. And this allows us to conclude that we have discovered a supermassive black hole at the center of our galaxy. Thank you very much for listening, and be sure to check out our other videos.